Hi everyone, and a very warm welcome to all our viewers. And in this particular video, we are going to discuss the PostgreSQL interview questions. So, guys, if you're working in IT, it is very important to have good understanding of databases. So now, every application in the IT industry, it has a front end, back end, and a database. So it doesn't matter what your profile is in the IT industry, whether you're a developer, you're a tester, or you're any sort of admin, it is very good to have SQL knowledge. And guys, PostgreSQL is one of the most popular databases out there. Like apart from PostgreSQL, we also have MySQL, SQLite, Microsoft SQL Server, and so on and so forth. But in this particular video, we are going to cover the most frequently asked PostgreSQL interview questions, wherein we will be covering the questions that are meant for the more experienced candidates, like those candidates who have at least 3 to 5 years of experience with Postgres. Okay, so in this particular portion of the video, we will be covering roughly 20 questions. So this question says, let's say we have a table representing the vacations booking. Okay, so there's a table called as vacations booking. And from that table, what we have to do, we have to write a query that returns the columns representing the total number of bookings in the last 90 days, last 365 days, and the overall number of bookings. So guys, as you can see on the screen, there are two columns over here. The first column, or the column on the left hand side, this is the input that we have. Like this is the column and this is the data type over here. So here in this table, vacations booking table, we have reservation ID, guest ID, check-in date, and checkout date. So these are the four columns that are provided as input. And the right hand side column, or the second column over here is, or the second table that we have is the output table. Like we want the output in this particular format. So over here also we have columns like number of bookings ID in the last 90 days, number of bookings in the last 365 days, and the number of bookings which is total. And the data type over here is integer. Okay, so I hope you guys have understood the question. So for the advanced candidates, it will be mostly, a query, advanced queries, or advanced scenario based questions. So for this particular question, what you can do is you can pause the video for a while. You can take a piece of paper and a pen and write down your possible answer over here. Okay. So once you write the possible answer over here, you can match it with the answer that we will be just discussing. To answer this query, what you have to do is, as you can see on the screen, first, let's suppose that there are two cases over here. And what are those two cases? In the first case, we are finding the total number of bookings in the last 90 days. So let's suppose the current date is 1st December 2024. So as you can see on the screen, the by default date format for Postgres is year, month, and the day. So this is the first case, last 90 days. And the second case is last 365 days. And thirdly, we will be having a count of the overall or the total number of bookings that are available in this particular table. So our query will look like something select. Obviously, we will be starting with select, and then we have to use a aggregate function sum. So what we are including in the first case? So in the first case, we are using the aggregate function sum, and we're defining the case when date add or the check-in date is the check-in date, that is our first column, and the interval over here is the 3 month. So that's why we have written interval 3 month, and which is greater than or equal to the date, like today's date. If it is in the specified date, then the value is 1, else it is 0. And then we are ending the case over here. And what do you want to name this aggregate function? We want to name it as num bookings last 90 days. So this is our first case. Similarly, the second case is when the check-in date is, we are defining again the interval, which is 1 year, greater than equal to the current date. And if it is true, then 1. If it is false, then 0. So this is how we are representing our case in case of 1 year interval. And you want to name it as num bookings last 365 days. So this is our second case. And the third part of this query is we also want to count the overall or the total number of bookings. So that is why we are mentioning over here count reservation IDs, like total number of reservation IDs, as num bookings total. And we are extracting all of this from the bookings table. So I hope you have understood this query. And now let's move forward for the next question. So the next question is again a scenario based question. And in this particular question, you have to provide a data analytics solution. So now what is the question over here? So let's say you work for an e-commerce website or an e-commerce company that receives the clickstream data from Kafka daily. So you're asked to design a data analytics solution for storing and querying the raw data with a 2-year retention period. The current data volume is around 600 million events daily. And what kind of data analytics solution would you design keeping the cost in mind? So guys, this is a very advanced question. Like if you're working for an e-commerce company, or if you have worked on these kind of scenarios before, like if you have truly gained a valuable hands-on experience in dealing with this kind of scenarios, I think you will be surely able to answer these kind of questions. So over here, let's break down this question is into few parts. So here we are receiving clickstream data from Kafka, Apache Kafka. So Apache Kafka is basically used for streaming data. And as a consultant, what you have to do, you have to provide a data analytics solution for storing and querying the raw data with a retention period of 2 years. And the current data volume is around 600 million events daily. So what kind of solution would you design keeping the cost in mind? So here we have to consider a very important parameter, that is the cost. So depending on this particular question, so what you would answer, like how you would answer this question. So you would answer it like, to design a cost effective data solution, what you can do is for storing and querying large volumes of clickstream data, like you can use a combination of Apache Kafka, which is the streaming platform, and for storing and analyzing this data, what you can do is you can use Apache Hadoop as well. So combination of Apache Kafka and Apache Hadoop might work in this particular scenario. Or you can also do is you can use a cloud-based solution. Like if you're using, let's say, AWS cloud platform. So in AWS, you have Amazon S3 for long-term storage. Like if you're using servers, then Kafka and Hadoop would do the job for you. But if you're using a cloud-based solution, like if you have your, the infrastructure is on the cloud. So in that case, if you're using AWS, so you can use Amazon or AWS S3. So PostgreSQL can be used for querying and the data analytics. And now what is the purpose of using Postgres over here? So using Postgres, you can leverage the columnar storage for efficiently querying the data. And implementing data partitioning with Postgres, you can do it based on the date or the user ID. And once you partition the data, what you can achieve is you can optimize the performance of the database. And since we have the condition of 2-year retention period, so what you can do is to satisfy that condition, you can regularly compress and archive the older data to manage the storage cost. So if you're able to compress and archive the older data, you will significantly reduce the cost of your data analytics solution. So this was the best possible answer for this kind of scenario based question. The next question is, describe the different types of user accounts and access control mechanisms in Postgres. So guys, in Postgres, roles can represent the users or the groups that are assigned privileges for database objects. That user roles can log in, while group roles manage privileges collectively. So those privileges are select, insert, and update control access. Roles can inherit the privileges from other roles as well. And here the authentication methods such as passwords, GSS API, SSPI, LDAP, and certificates are also present. Apart from that, row level security or RLS allows fine-grained access control by restricting which rows a user can access to. So these are the certain mechanisms that ensure secure and controlled database access. The next question is, explain how would you migrate data from one database system to Postgres. So guys, this is again a real-time scenario based question. Like if you're working for a company, so let's say you have your database systems on a different SQL based database like MySQL or Oracle or some other database, and now you're planning to migrate all of your data from that system to Postgres. So how would you do that? So to migrate data from one database to Postgres, the first and foremost thing what you have to do is you have to export the source database schema and the data. So schema and the data is very much important. Like this is the primary criteria that you must satisfy in order to migrate to Postgres. So after that, what you have to do, you have to use tools like pgdump for Postgres or other such relevant or equivalent tools for other databases as well. After that, what you have to do is you have to create the schema in Postgres using the exported SQL script and then import the data. Next, what you can do is you can use tools like pgadmin, psql, or any third party ETL tools that can facilitate this process efficiently. And last but not the least, the final step over here is you have to verify the data integrity once the migration has been completed. The next question is, how can you stop a Postgres SQL server? Like, can you stop a particular database in the Postgres SQL cluster? So to answer this question, if you are using a Windows based system, so the command for Windows based system is, as you can see on the screen, the command is pg_ctl and then space -d and then the path of the database directory that is present on your system. So the first step over here would be to locate the PostgreSQL database directory. And once you have the path of the directory, the command is pgctl space -D and then the path and lastly space stop. So this is for Windows based systems. If you're using Linux based system, the command is very simple. You have to just type sudo space service space PostgreSQL space stop. And last but not the least, if you're using a Mac based system or a Mac OS, then the command is pgctl-d. Similar to Windows, you also have to find the location or the directory of the Postgres, and that path you have to type here like user local var Postgres and then finally space and stop. So based on the system that you're using, these are the techniques to stop a PostgreSQL server. And to answer the second part of the question, like can you stop a particular database in the PostgreSQL cluster? So the answer to this question is no. PostgreSQL does not allow the user to stop a specific data in the cluster. The next question is, why is it a standard practice to explicitly put foreign key constraints on related tables instead of creating a normal big int field? So when considering foreign key constraints, when you should consider a cascade delete or a set null? So guys, using foreign key constraints in Postgres. Now, why do you use the foreign key constraint in a Postgres database? So this ensures the data integrity by enforcing the relationships between the tables. Also, it prevents often records and maintains consistency across the related tables that are present in the database. And foreign keys also enable cascading actions. And here, what you can do is you can use cascade delete when you want related records to be automatically removed when the parent record is deleted, and set null is used when you want to retain related records but nullify the foreign key value. So guys, the next question is again a scenario based question. So the question says, let's say that you work for an advertising firm. So over here you have a table of users impressions of ad campaigns over time, and each impression ID consists of the values of user engagement specified as excited, okay, or bored. So over here, what you have to do is you have to write a query to find all of the users that are currently excited and have never been bored with a campaign. So as you can see on the screen, the first column over here or the first table over here is that of a input. So this is the input that you have been provided with. So there are four columns. The first one is user ID. The second is DT or the date. The third column is the campaign ID and the fourth column is the impression ID. So this is the input that we have, and along with columns you also have the data types over here, and the output is the second table. Like the output of this query should look like the first column will be user ID. There's only one column over here, and the data type of that particular user ID is integer. So how will you write this particular query? So guys, as you can see on the screen, firstly, you can pause this video, you can write your query, and once you have written the query, you can match it with the query that you can see on the screen right now. So our query will look like select distinct user ID. And once you have the distinct user ID, from where you have to fetch these IDs from add impressions, which is our input table. So select distinct user ID from add impressions. And now to specify the conditions, like we want the condition as excited and never been bored. So using where we can specify these two conditions. So where impression ID equal to excited and user ID not in. So for those users who have never been bored with a campaign, we are specifying that using and user ID not in. And inside not in, again, we are writing one query, which is a nested query. So select user ID from add impressions where impression ID is bored. So once you have all of those results, then you are negating those results using not in. So I hope you have understood this particular query. And now let's move to the next question. How to handle exceptions in pgSQL? So basically, exceptions are those particular situations or conditions where you have to provide proper explanation or proper messages to the user so that they should understand if they are doing anything wrong or if they are unknowingly doing a mistake. So in that particular case, you have to provide the exceptions. So over here, as you can see on the screen, we are trying to handle an exception over here. So how we can define an exception? So over here, we are defining an exception using do, and then you have the $2 marks, and then the begin statement. So after the begin statement, what we are trying to do is, we are in this particular scenario, what we are doing is, we are inserting a duplicate record or a duplicate key inside our table. So how are we doing that? Insert into employees. So we have an employees table, and inside that employees table, we have two columns, employee ID and name, and we are inserting values. So what are those values? One is the employee ID and the name is John Doe. So since this record is already present in the table, like whenever we are inserting a duplicate record or a duplicate key inside a table, we have to raise an exception. And how do we define the exception? We are writing the keyword exception and what is the required action once you encounter that exception. So once you encounter any duplicate record or a duplicate key inside a particular table, so what you have to do is, it is violating our unique violation. So the constant of unique key or the unique records is violated over here since we are inserting a duplicate record. So what you have to do is, you have to raise notice or raise message like duplicate key error. So once you get this error on the screen or the CLI terminal in Postgres, so the user will automatically understand that this is a duplicate record and they will appropriately do whatever is required in that particular case. So once you have this raise notice like duplicate key error, you have to end the exception, and you, like in this particular first statement, you had $2 marks, and at the end of the exception also you have the $2 symbols. Okay, so this is how you define an exception is in Postgres. The next question over here is, explain the concept of JSON data types in Postgres. So guys, Postgres supports different types of data types, and one such data type is JSON. So JSON is basically JavaScript object notation data, and with Postgres, you can store and query the JSON data type as well. So this is basically a semi-structured data, and with JSON, you can use JSON or JSONB types, where JSONB is a binary format that is more efficient for indexing purpose. So for example, as you can see on the screen, here we are writing a query And in this particular query, we are using the JSON data type. So basically, guys, JSON data type, like you can, so guys, data type, basically it's a semi-structured data type, and it works in the pair of key value. So over here, as you can see on the screen, create table products. So we are creating a table products where the first column will be ID, which is a serial primary key, and the second column is the details. So the details we are providing in the JSON binary format. So once we create this table, the table will be created. And now while inserting values in this particular table, what we are doing is we are using the insert query, like insert into products, which is our table, details, and we are providing the details in the products table, like we are providing the values. So in details column, what we are providing, name and price. So in the products table, we have the details. The detail will be name, which is the key, and what is the value, like colon, key, colon, value, comma, key, colon, value. So what are the details that we are providing for this particular column? So we are providing name as laptop and price as 1200. So using this insert into product details values, we are providing details such as name and price. The next question is, what does write ahead logging do? So write ahead logging, or WL val, is a method used by Postgres in order to ensure the data integrity and durability. So basically, val works by recording changes to the database in a log file before they are applied to the actual data files. And now, why you must use val? So basically, using val, the Postgres can recover from crashes. Postgres can also support data replication using val. And finally, Postgres ensures durability with the help of val, or write ahead logging. The next question is, what is the role of vacuum in Postgres? So basically, in Postgres, vacuum is a crucial process for managing and reclaiming the disk space which has been occupied by deleted or outdated data. Vacuum is essential for maintaining the performance and the efficiency of Postgres database, especially in scenarios with frequent updates and deletes. And now there are two tasks that vacuum performs in PostgreSQL. The first task is that of freeing up the disk space. So when the data is updated or deleted in Postgres, it is not immediately removed from the disk. Instead, what happens is it becomes marked as reusable by future inserts. So basically, the vacuum process identifies these reusable data pages and makes the space available for future use. And the second task that can be accomplished using vacuum is updating the statistics. So vacuum analyzes the distribution of data and updates the statistics used by the query planner. So accurate statistics help the Postgres choose optimal query plans, and this results in the improved performance of Postgres. The next question is, how do you use advisory locks in Postgres? So guys, advisory locks are nothing but user defined locks, and that allow the coordination between the database sessions. So unlike the row level locks, advisory locks do not conflict with the other types of locks, and they can easily be acquired and released voluntarily. So basically, to acquire an advisory lock, what you can do is you can use the pg advisory lock function. So how do you do that? You can write select pg advisory lock and you have to provide the lock ID. Similarly, to release an advisory lock, you can use the pg advisory unlock function. So how do you do that? You can simply write select pg advisory unlock and you have to provide the lock ID over here. So advisory locks are often used for application level synchronization or to implement custom concurrency control mechanisms. The next question is, how do you use the pgbouncer connection pooler with Postgres? So to understand how do you use the pgbouncer connection pooler with Postgres, let's quickly understand the definition of pgbouncer. So pgbouncer acts as the middle layer between the application and the PostgreSQL server, managing a pool of database connections. So it handles connections requests from multiple clients, and it reuses idle connections and provides more efficient use of database resources. So by using pgbouncer, what you can do is you can achieve connection pooling, load balancing, and this helps to improve the scalability and performance of your application when interacting with a PostgreSQL database. And now if you talk about how to use the pgbouncer connection pooler, so over here, what you have to do is you have to first install and configure pgbouncer on a separate server or a machine. After that, the second step is you have to edit the pgbouncer.ini configuration file to specify the PostgreSQL servers that you want to connect to and the pool mode, which can be either transaction or session, and other relevant settings. The third step is to start the pgbouncer service. And finally, you have to modify your application database connection settings to use the pgbouncer server instead of directly connecting to PostgreSQL. The next question is, what is the difference between a clustered index and a non-clustered index in Postgres? So the important difference between a clustered and a non-clustered index in Postgres is that clustered index is an index type that is used to store tables or the table data rows according to their key values. The next question is, what are the three phenomena that must be prevented between concurrent transactions in PostgreSQL? So there are three levels of transaction isolation that are used in SQL standard regarding three phenomena that must be prevented between concurrent transactions in Postgres. So these three unwanted phenomena are, as you can see on the screen, the first one is a dirty read. So a transaction is called a dirty read when it reads the data written by concurrent uncommitted transaction. The second unwanted phenomena is non-repeatable read. So this specifies a transaction that rereads the data it has previously read and then finds another transaction that has already modified that particular read. And the third type of unwanted phenomenon over here is the phantom read. So phantom read basically specifies a transaction that re-executes a query, returning a set of rows that satisfy a search condition and then finds out that the set of rows satisfying the condition has changed due to another recently committed transaction. The next question is, what do you understand by an inverted file in Postgres? So in Postgres, an inverted file is an index data structure that is used to map the content to its location to a database within a document or in sets of documents. So it generally includes the distinct words found in a text and a list containing occurrences of a word in the text. So it is used in a data structure for document retrieval systems to provide the full text search. The next question is, what is the purpose of pgstat SSL view in Postgres? So the pgstat SSL view in Postgres, basically it provides the information about the current SSL or TLS connections established within the server. So it displays or highlights statistics related to the encryption and the security parameters of these particular connections. So this particular view includes details such as the process ID of the connected session, the connections SSL or the TLS version, the cipher suite that is being currently used, and the SSL or TLS compression status and other relevant information. The next question is, what is a hot standby in Postgres and how does it work? So hot standby in Postgres is a feature that allows you to run a read-only queries on a replicated database while it is replicating data from the primary database. So basically this setup provides high availability by allowing the replica to be used for query processing and thus offloading some of the workloads from the primary database. So hot standby works in conjunction with streaming replication, where the replica continuously receives val records from the primary database. In case of event of the failure of the primary, the replica can be promoted to take over as the new primary, minimizing the downtime. The next question is, how do we implement table partitioning? So guys, table partitioning will allow you to split the large table into small portions, which can be manageable pieces known as partitions. So every partition stores the subset of the data as per the specified partitioning key. So now to implement the table partitioning, there are a few steps that we must follow. So the first step over here is you have to create the parent table with all of the required columns, including the partitioning key. Once we have that, the second step is you have to create the child table that will be inherited from the parent table. So every child table represents a particular partition of the parent table. The third step is you have to define the constraints on every child table for limiting the partitioning key values. And last but not the least, you have to create the indexes on the child tables for optimizing the query performance. The partitioning features of Postgres offers automatic routing of data to proper portions as per the partitioning key, and this leads to simplified data management and enhanced query performance. So at the end of the day, why do we implement partitioning? Basically, it leads to simplified data management and enhanced query performance. The next question is, how do we implement sharding? So guys, sharding basically refers to the horizontal partitioning data throughout the multiple shards or servers for distributing the load and scaling the database system. So there are a few steps that we must follow in order to implement sharding or the horizontal partitioning. The first step is you have to set up the shard server. So what do you mean by that? So here you have to create the individual Postgres clusters or the instances for every shard. So every shard must have its own server like storage, processing, and memory. The second step is to determine the shard strategy. So here you have to select a strategy to partition the data through the multiple shards that you have. So the strategies could be like hash based sharding, range based sharding, or a combination of both. The third step is you have to implement the application logic. So here you have to modify the application code and use a middleware to route the data and queries to the proper shard as per the data distribution rules. And once you have implemented the application logic, the fourth step is to define the data distribution rules. So here you have to determine how to distribute the data throughout the shards as per the selected sharding strategy. And last but not the least, you have to manage the data synchronization and consistency. So in the fifth step, you have to implement mechanisms for ensuring data consistency throughout the shards like logical replication, data synchronization, and distributed transaction tools. So guys, with this, we have come to the end of this session on PostgreSQL Server interview questions. If at all you have any doubts or queries related to this session, then you can write them in the comment section and we will try to resolve your queries as early as possible. So guys, thank you so much for being with us and I wish you all the very best for your upcoming Postgres interview.